Hi everybody, my name is Ken and I am your friendly animator and video editor from Kenimation Studios.
Who you looking at? Who you looking at?
I am currently finishing my master's degree in business analytics, and in today's topic I will be introducing to you one of the coolest modeling technique that I have learned. But in order for us to do that, we have to understand what is deep learning and if it's any different with machine learning. Have you ever wondered how programmers work on your passwords, especially on your face recognition? Or even on how QR codes work when you're paying with your GCash or any bank transfers? All of this is a product of deep learning. But how do we simplify everything for us to understand deep learning? Deep learning is a subset of machine learning, which in turn is a subset of artificial intelligence. Artificial intelligence is a technique that enables a machine to mimic human behavior. Let's understand deep learning better on how it's different from machine learning. Say we create a machine that could differentiate between tomatoes and cherries. If done using machine learning, we'd have to tell the machine the features based on which the two can be differentiated. These features could be the size and the type of stem on them. With deep learning, on the other hand, the features are picked out by the neural network without human intervention. Of course, that kind of independence comes at a cost of having a much higher volume of data to train our machine. Now let's dive into my main topic, which is the neural networks. Neural networks take in data to train themselves to recognize the patterns in these data and then predict the outputs with a new set of similar data. Let's understand how this is done by identifying handwritten numbers. This number is present as an image with 28 by 28 pixels, which amounts to 784 pixels. Neurons is the core entity of neural network where all the information processing takes place. Each of the 784 pixels is fed to a neuron in the first layer of our neural networks. This forms the input layer. On the other end, we have the output layer, with each neuron representing a digit with the hidden layers existing between them. The information is transferred from one layer to another over connecting channels. Each of these has a value attached to it and hence is called a weighted channel. All neurons have a unique number associated with it called bias. This bias is added to the weighted sum of inputs reaching the neuron, which is then applied to a function known as the activation function. The result of the activation function determines if the neuron gets activated. Every activated neuron passes on information to the following layers. This continues up till the second last layer. The one neuron activated in the output layer corresponds to the input digit. The weights and the bias are continuously adjusted to produce a well-trained network. So where is deep learning applied? As our example earlier, the generated QR codes are then analyzed using neural networks to identify that they are tied within your banking details. Once that it was verified that this is indeed your account, it gets the correct amount that you wanted to input. For some, they include additional program to input additional charges. In medical care, neural networks detect cancer cells and analyze MRI images to give detailed results. But it has several cons or limitations too. The first, as we discussed earlier, is data. While deep learning is most efficient way to deal with unstructured data, a neural network requires a massive volume of data to train. Let's assume we always have access to the necessary amount of data processing. This is not within the capability of every machine. And that brings us to the second limitation. Computational power. Computational power training in neural network requires graphical processing units, which have thousands of cores as compared to CPUs. And GPUs are, of course, more expensive. And that's about the neural networks and deep learning. If you like this video, please click the subscribe button for more contents. Goodbye!